Now on the basis of denticity we have already classified ligands into unidentate, bidentate, polydentate. Now depending upon whether the the ligand is going to be symmetrical or unsymmetrical, we classify into two categories: symmetrical ligand and unsymmetrical ligand. So in symmetrical ligand, what is there? The two donor sites are actually same. You can say the atoms which are the ions which are going to donate electrons, which possess the electron, or which are going to link to the metal atom, are exactly same. For example, we have this thing ethane 1,2-diamine. So here it is going to link with this NH, and as both the NH2 are same, so obviously it is going to be a symmetrical ligand. An unsymmetrical one is that in which both the groups are different, like both the donor sites are not similar. For example, we have glycinatoion. What is that? It is NH2, CH2, CO negative. So here it can link with by this N also, because it possesses an extra electron, it can link with this side also. So that means here both the ions or groups actually, they are actually different. So that means it is an unsymmetrical ligand. So now we have one more effect, like as I told you, depending upon symmetrical or unsymmetrical, we have another kind of effect, that is the chelating effect, or you can say the chelating ligand. What's that? For example, I have this ethane 1,2-diamine. So as you can see that it is symmetrical. If I make it if I just react this thing with the copper, so what do I get? Copper 2 positive. We know that copper is 2 positive. So it is going to link in this way. NH2, coordinate bond, again NH2, CH2, NH2, CH2, these. So this lead to the formation of this kind of compound, and where this ring is formed actually is called as chelate. So what is chelate actually? If somebody is going to ask you, are going to answer in this way, that when we have more than you can say the di or polydentate ligands particularly, so when they actually link with the central metal atom ion and just give rise to a ring kind of structure, then that ring kind of structure is called as chelate, and it is somehow more stable than the monodentate ligand or the unidentate ligand which is linked to the central atom. And why it is stable? Because it leads to increase in entropy. As you can see there, it leads to more disorder. Disorder means increase in entropy and means randomness, and due to this it becomes favorable to form this chelate. And so if somebody is going to ask you that why it's stable, you are going to say that it is stable due to chelate effect, because here the groups are actually joining to form a ring like compound, and due to formation of this ring like compound there is more disorder, more randomness, more entropy, which is a favorable condition. So that is why it is more stable. So now coming on to one more ligand, depending upon the symmetrical and unsymmetrical, ambidentate ligand. For example, we have this SCN, that is thiocyanate. This thiocyanate ion can actually link with the metal atom from this side also and from this side also. But at a given time it is linked to the central atom either from the S side or from the N side. Means the both linkage cannot be occurred at the same time. Either it is going to link through S or it is going to link through N. So such kind of ions or the groups actually which can link to the central atom in both the ways, either of the ways, then they are called as ambidentate. So as we can have the coordination this way also, right, and we can have the coordination this way also. So it can be linked by thiocyanate or it can be linked by isothiocyanate. So because it has the two groups on either side and it can link to the central atom through one kind of linkage at a particular given time, that is why it is called as ambident ligand. Likewise, we have NO2. NO2 is particularly like this. So it can link with the metal atom this way also, and it can link with the metal atom through oxygen also. So that means again it can link in both the ways, so it is a ambident ligand. So this is what is the symmetrical and unsymmetrical. So symmetrical ligands, depending upon the, if we see that depending upon the lone pairs, we divide them into, that is depending upon denticity, we divide them into unidentate, bidentate, polydentate, and depending upon their symmetry, they are divided into symmetrical and unsymmetrical. Symmetrical means when both the ligands or the groups or the donor sites actually, when they are similar, it's symmetrical. When the donor sites are different, it is unsymmetrical, right? And like depending upon that, we have the chelating ligand and ambident ligand. Chelating effect, that is the chelating ligand when it is linked to the central atom. So what happens, it leads to the formation of ring like structure, and it is somehow more stable than the unidentate linked to the central metal atom or a bidentate one. The reason being because it leads to formation of ring like structure, more disorder, more entropy, more randomness, and it is a favorable condition, right? So due to chelate effect, actually it is very stable. And coming on to the ambidentate, ambidentate is obviously the one which you can say which can link with the metal atom from either side, means either donor side, but the linkage is only one kind of linkage we observe at a specific time, right? But it has the property that it can link from either side, as I told you, thiocyanate and isothiocyanate, likewise NO2, it can link with N also, it can link through O also. So this is what is the ligands. So you should know actually that ligands are actually the groups which are electron donating, they have the donor sites, they have the lone pair, and they are just going to link with the central atom. Depending upon denticity and symmetry, we just divide them into bidentate, unidentate, polydentate, likewise the chelating ligand and the ambident ligand, right? So we are going to start with the coordination number now.